This is another example. So what is happening here? The first line N10, that is the first line. In this line, T2, M6, this is for selecting the tool and changing the tool. Then spindle speed, okay, spindle speed 1800 RPM, and M4 is the spindle rotation. Okay. Then the next line says Z21, that is for 21 is for selecting the unit system. So this is metric system in millimeter. Z90 is Z90 is the coordinate system. That Z90 and Z91 are the coordinate system. We selected Z90, that starts from all the dimensions are selected from the 0 point, that is absolute coordinate system. Then in the third line, we started the machining. Z01 is the linear interpolation, and this is the initial point x3, y1, z0. So this is the initial point x3, y1, and z0 means that is the top surface of the machining part. Then next line, z -1, that means the tool will go down and create some depth. So okay, then we'll start machining along y-axis only. So from here it will move straight up y7, that you can see y7, it will come here. Then it will go along x-axis only, you can see x. If I don't change z code here, the z01 will remain same for the next 3 lines, you can see. So x 4.5 is this point here. Okay, so now I need circular interpolation. That's why in the next line you can see Z02. So Z02 is the circular interpolation, and for circular interpolation you need the end point of the circular interpolation. So this is the end point for this circular interpolation, that is x 4.5 and y4. X 4.5 is here and y4 is here. So this is the end point for the circular interpolation. And then you can see I and J. I and J are basically determining the center point for this circular interpolation. Okay, and that center point is expressed in terms of the distance from the initial point to the center point, from the initial point to the center point. Okay, so I is the distance from initial center point to center point along x-axis, and J is along y-axis. So as you see, I is 0 here because it's 0 along x-axis, but y is 1.5, negative 1.5, that is the distance along y-axis, because it is this point, center point is 5.5, but initial point was 7 along y-axis. So 7 minus 5.5 is 1.5. Because it is going downward, that's why it is negative, because you need to go downward to find your center point from the initial point, that's why it is negative. Okay, now you are here, or circular interpolation is done. Now you need a linear interpolation to go in this point. Okay, so that's why Z01 again, and x3 is, you can see x3 is this point. This is the x-axis 3 point. Y is not moving, so from here to here it is only x-axis, so that is 3. Then x 4.5 again to come back in this position for getting the initial point for the second circular interpolation. So the second circular interpolation starts in line 100, and here Z02 code is for circular interpolation. So from here, now for the circular interpolation, you need the endpoint of the circular interpolation. This is the endpoint of the circular interpolation, and that is x 4.5 y1. You can see x 4.5 y1. So this is the endpoint for the circular interpolation, and you need I and J again, because I is 0, y from the initial point to the center point. Along x-axis this is 0, but along y-axis this is 1.5, because it's coming from along y-axis, it is coming from 4 to 2.5. This is 4 to 2.5 along y-axis. So that's why z is negative 1.5. Okay, so once you are here, you need to go to this point. This is x3, y remains 1, y remains the same. Because y remains the same, you don't need to write y again, just write x, that's enough. So it will go here, and then you need to retrieve your cutting tool from the depth. So I wrote z0 again. Okay, so at the end you need basically I need to write in 130 another line, and in 140 the last line. Okay, so let me save this, and I am to test this code here. Let's try to test this code and simulate. So that's what you see here. B is drawn. You can see the depth, 1 millimeter depth from the surface, top surface.